Hey guys, what's up? I'm going to look at resistors in parallel and how we calculate the total resistance of a number of resistors in parallel. So I've got two circuits here which are actually equivalent to each other. They're exactly the same. On the left, I've got an EMF supply which has got a voltage V, and the current that it produces is I. This current then gets split between three resistors in parallel. So we get I1, I2, and I3. And because of Kirchhoff's laws, we know that the total current must be equal to I1 plus I2 plus I3. That's Kirchhoff's first law. The sum of the currents entering a junction is equal to the sum of currents leaving a junction because of conservation of charge. So we know the currents, but we also know, because of Kirchhoff's second law, that the sum of EMFs in a loop is equal to the sum of the potential differences in a loop. Therefore, the potential difference across each of these resistors here is V. It's the same for every single one. This circuit is identical to this circuit B, which is the sort of simplified version of this circuit. We've combined all of those resistors into one total resistance. And we can say from circuit B that the current must be equal to V over RT. We've just got that from Ohm's law, V equals IR. All we've done is rearrange it for I. Now let's have a look back over here in circuit A. If I is equal to I1 plus I2 plus I3, and we know that I is V over R, we can say that I is equal to V over R1 plus V over R2 plus V over R3. But we already know that I is equal to V over RT, so I can substitute that in for here. So get V over RT is equal to V over R1 plus V over R2 plus V over R3. And we can simply divide through by V, and all of these V's disappear. And that gives us our total resistance. We end up with 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And we could do this for any number of resistors in parallel. And it's really important to know this derivation, but also know how to use this to solve problems when we've got resistors in parallel. So let's have a look at a couple of worked examples. In example A, I've got two resistors, a 20 ohm resistor and a 50 ohm resistor, and they're in parallel. So all we're going to do, excuse me, is calculate the total resistance. So 1 over RT is equal to 1 over R1 plus 1 over R2, which gives us 1 over 20 plus 1 over 50. So 1 over RT is equal to 0.07. We're not there just yet. What we have to remember to do, and a number of students always forget this, is to take the reciprocal. We need RT, not 1 over RT. So RT is 1 over 0.07. So the total resistance of those two resistors in parallel is 14.3 ohms. And you'll notice that that is less than either of the resistors themselves. When resistors add in parallel, the total resistance is always less. Let's have a look at the next one. We've got three resistors this time. Therefore, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So we get 1 over 100 plus 1 over 200 plus 1 over 300, which gives 1 over RT to be 0.0183. But we have to remember to take the reciprocal. So RT is 1 over 0.0183. So the total resistance of these resistors in parallel is 54.6 ohms. It's really easy. You just got to remember to use the formula and to take the reciprocal at the end. So the formula for resistors in parallel is 1 over RT is 1 over R1 plus 1 over R2. You need to know the derivation, and you need to know how to apply it to simple problems. That's it. Thanks for listening. See you all soon.